So question 6 is about some electron configurations. So we're going to write down the electron configuration. So you find chlorine in your periodic table. And if you find chlorine, you'll see that it's got 17 electrons. 1s2, 2s2, 2p6, 3s2. So it should be 3p5, but that would be chlorine, and a chloride ion has got one extra, 3p6. So we're adding one extra onto the chloride ion. Now with these transition metals, these next two, what I suggest you do is you ignore the charge for a second and you use a pencil to write down the full electron configuration of just Fe. So Fe is number 26 in the periodic table. So you would write down the first 26 electrons. So you get past the first 18 up to argon. Leave a little gap, fill the 4s first, then go back and fill the 3d, it would be with 6. Now I suggest you use a pencil because now you can remove 3 electrons, the outer 3. So we had 3p d6 4s2. We're going to delete the last 2 and 1 of these so that we've removed 3 electrons, and now we're at 3d5. So we're going to do the same for zinc. Zinc is number 30 in the periodic table. So we go along, we do the first 18 that give us argon. Leave a space, put 4s2, and then we'd need 3d10. But because we're doing zinc 2+, we then lose the 4s first. So this common mistake with transition metals is to just do 28 electrons or 24 electrons, 23 electrons for Fe3+, and to do it from first principles, and then you will end up with 4s2, 3d3, which is not the right answer, because the 4s are lost first as well as filled first. Now I've been asked, state which of the elements, magnesium or aluminium. So you need to find magnesium and aluminium in your periodic table. You'll find them both in period 3. So they're next to each other in period 3, although there's a big gap in the periodic table at that point. So we've got period 3 goes sodium, magnesium, aluminium, silicon, etc. So remember the graph, up 2, dip, up 3, dip, up 3, across a row, when things are in the same row. Is this a normal question where same shell, similar shielding, more protons, or is this one of the dips? And this is one of the dips. Who has a lower answer? Aluminium, and this is very similar to a question earlier on in the paper. Why does it have a dip? Because it's outer electron, not it. Aluminium is not in a new subshell. Outer electron in a new subshell. Don't say shell. Not in a new shell. They're both in the third shell. This is ending 3s1, magnesium's ending 3s2, aluminium's ending 3p1. Still in the third shell, just a new subshell, which is higher in energy, is the best answer. Higher in energy, which makes it slightly easier to remove.